Now we're going to talk about areas of basic shapes. Okay, now we have a square, and you know a square has all sides equal. Okay, now we have a rectangle. A rectangle has opposite sides equal. You have a trapezium. Okay, you have a parallelogram. A parallelogram has opposite sides equal and parallel to each other. Okay, now we're going to talk about the areas of these basic shapes one by one, and then we'll solve questions on them. Area of a square. Before we even go ahead to go to area of a square, all these areas that we keep hearing about, area of this, area of that, what is really the meaning of area? Okay, it actually means the space inside a plane. Okay, for example, this is a plane square. The whole space inside it is the area. The whole space inside this one is the area. The whole space inside this one is the area. The whole space inside this one is the area. So it's the, let's write it down, is the space inside a plane. Okay, and is measured in squares. Always remember that, measured in squares. For example, if the unit here is centimeter, it's going to be centimeter squared. If the unit was in meter, it's going to be meter squared. It's always measured in squares. Okay, so now area of a square is one of the sides squared. Why? Because all sides are equal. It could have been length times width, but since the length is the same as the width, we just square it. Okay, this is the same thing as length times width. Since length is the same as width, is the same thing as length times length or width times width. So we just square one side. Okay, now for rectangle, we'll have the area to be length times width, really. Now since this one and this one, they are not the same size, we can't go ahead and say okay, is one side squared. No, we have to multiply out, really. Then for a trapezium, this trapezium, we can call this the height, the real height. Okay, now you know when you divide a trapezium this way, this is more like a rectangle, that's a rectangle and two triangles. Okay, and you know that the area of a rectangle is length times width. Okay, and then the area of a triangle is half base times height. Okay, half base times height. Now I'm writing 2 because I have 2 of the triangles. So if this cancels out this, you have length times width plus base times height. Okay, now this is basically how you would have gotten the area of this trapezium. Okay, but now we have a more easier formula. Okay, now bringing it together, you just be able to take it this way as half a plus b times h. Now what is this a plus b? Well, we're using this half because half base times height, okay, is half base times height is a formula for a triangle. Then length times width is a formula for rectangle. So combining it together, this one is more like combining it, and then we'll be able to get this. Okay, and then your a is somewhere like this and b is here, everything here. Okay, a is everything here, then your h is this. Okay, doing it that way, you'll be able to get this and this. It's either you just decide to just break it down into rectangle and triangle, but it will really waste your time instead of picking this formula. So it's just wiser to pick this formula. Okay, have a plus b times h. Now for a parallelogram, the area, parallelogram is like a square, but it's just that these two sides are parallel and these two sides are parallel. Okay, so the area is just base, instead of base times this, now you're going to have a vertical height. Okay, it's slanted this way. There are two parallel lines, so you can't just say the base times this parallel line. So we have to have a vertical height. So it's going to be base times vertical height for a parallelogram. Okay, now bearing this in mind, we're going to solve this question. Now this question says that the length of a rectangle is 35 centimeters, correct to the nearest centimeters, and the width of the rectangle is 26 centimeters, correct to the nearest centimeters. Calculate the upper bound for the area of the rectangle. Write down all the figures in your calculator display. Now this question actually covers two areas, upper bounds and areas, but we'll do it to the best of our ability. Okay, now you have 26 centimeters here, and here you have 35 centimeters. Now we're told that all this one was corrected to the nearest centimeter, that's the nearest 1 unit. Okay, now the thing about upper bound is, if you correct to the nearest 1 unit, you're looking at 1. Okay, so you divide by 2 to get the unit you're going to add or subtract to get the upper and lower bound respectively. When you divide by 2, you have 0.5. So if you have this scale now, you have 26 centimeters to be here. So your upper bound, for you to get your upper bound, you add 0.5 to 26. So you have 26.5. For you to get your lower bound, you subtract 0.5 from 26, you have 25.5. Now this is your upper and this is your lower. So also for this one, you have 35 centimeters here. Now it's to the nearest 1 unit again, so it's still 1 unit, then you divide by 2, that's 0.5. So you add 0.5 here, you have 35.5. When you subtract, you have 34.5. So now we have our two upper bounds, and we are asked to calculate the area for the upper bound. So the area will have to be 26.5 times 35.5, and that's going to give us 26.5 times 35.5, 940.75 centimeters squared. Now that's the upper bound area for this rectangle. Okay, now let's look at another question. Now the diagram below shows a large rectangle of length 2x plus 6 and width x centimeters. A smaller rectangle of length x centimeters and width 3 centimeters is cut out and removed. The area of the shape that is left is 100 centimeters squared. Show that 2x squared plus 3x minus 100 is equal to 0. Okay, and we also have to calculate the length of the smaller rectangle. Correct your answer to 3 significant figures. So we have that this is a rectangle, and we're told that this was cut out from here. You have this as 3 and you have this as x. You have this as 2x plus 6 and you have this whole as x. The area of a rectangle, we know it as length times width. That is length times width. Okay, now area of the big rectangle is equal to x times 2x plus 6. Okay, which is going to give us 2x squared plus 6x. Okay, now the area of this small rectangle, is x times 3, that's 3x. Okay, but now we're now told that the area of the shape that is left is 100 centimeters squared. That's this other one, this shaded part now. The area left is 100 centimeters squared, and to get that, you just subtract this small area from the large area. Okay, so you have the area left is going to be 2x squared plus 6x minus 3x is equal to 100. We're given that is 100. Okay, now this minus this is going to be 2x squared plus 3x is equal to 100, but we're told to prove that 2x squared plus 3x minus 100 is equal to 0. To pull this to this side, you have 2x squared plus 3x minus 100 equal to 0. So it's proved. Okay, we've been able to prove that. Now we're now asked to calculate the length of the smaller rectangle. That's this length, x. Okay, we're told to find x. Now from here, now we'll be able to find our x using our almighty formula, because when you multiply out this, you have 200. So you can get checking this to see if you have two factors that can add and give you 3, and then or multiply to give you 200. We have 2 and 100. We have 4 and 50. We have 5 and 40. We have 10 and 20. Actually, we're asked to correct our answer to straight significant figures, so you don't even need to start doing this. You just know straight away that it doesn't have whole number factors. Okay, you go ahead and use your almighty formula, and the almighty formula says x is going to give you minus b plus or minus root of b squared minus 4ac all over 2a. Why this is our a, this is our b, and this is our c. Okay, now your x is going to give you b is 3, so you have minus 3 plus or minus root of our b is 3 squared minus 4 into a is 2 and c is minus 100 all over 2 into a is 2. Okay, so you have our x to be minus 3 plus or minus root of, this is 9, 100 times 4 is 400 times 2 is 800, minus times minus is plus, so plus 800. Okay, and all over 2 times 2 is 4. So we have our x to be minus 3 plus or minus root of 809 all over 4. So we have our x to be either minus 3 plus root of 809 over 4 or minus 3 minus root of 809 over 4. Now let's calculate that. Root of 809. Okay, minus 3 divided by 4. You have this to be 6.3607, and you have root of 809 you have this one to be negative 7.860. Okay, now since we're actually looking for the size, we're going to leave this negative value and work with the positive value. So this is going to be our answer. Then correct to three significant figures. We have 1, 2, 3. So it's going to be 6.36. Correct to three significant figures. Now that's the value for x. Okay, so that's it for areas or shapes of all these quadrilaterals and all that. So once you're able to know the formula, you solve the question.